So find the limit of 4x plus 5 over x squared plus 1 as x approaches 0. So again, to find this limit, first divide n of x and d of x by the highest power of x. So what is the highest power of x? From this equation, we have the x squared. So we divide all of the terms by x squared. So that is equal to the limit of 4x over x squared plus 5 over x squared divided by x squared over x squared plus 1 over x squared as x approaches infinity. Then cancel out x, cancel out 1x, cancel out x squared, cancel out x squared. So rewriting this equation, so we have the limit of 4 over x plus 5 over x squared divided by 1 plus 1 over x squared as x approaches infinity. So after that, we can find the limit of this equation as x approaches infinity by simply substituting infinity in all the x's. So this is equal to 4 over infinity plus 5 over infinity squared divided by 1 plus 1 over infinity squared. So 4 over infinity is equal to 0. 5 over infinity squared is 0. 1 over infinity squared is 0. So we have now 0 over 1, which is equal to 0. So this is our answer, 0. So the limit of 4x plus 5 over x squared plus 1 as x approaches infinity is equal to 0. Is it clear? Okay, next example. Okay, example number 3. Find the limit of x cubed plus x plus 2 over x squared minus 1. So this equation is a bit tricky. We need to simplify first the expression, and we shall apply the division of rational expressions. So by doing that, we have x squared minus 1 divided by x cubed plus x plus 2. So applying division of rational expressions, x squared divided by x cubed is equal to x. X times x squared is equal to x cubed. X times 1 is x minus x. So minus, cancel, distribute negative sign. So this will become positive. X plus x is equal to 2x. Then bring down to plus 2. So since x squared cannot be divided by 2x, so our answer will be x remainder 2x plus 2. So rewriting this equation, we have the limit of x plus 2x plus 2 divided by x squared minus 1 as x approaches infinity. So this will become our working equation. And after simplifying our expression, we can now divide the highest power of x. So what is the highest power of x? We have x squared. Using the properties of limit, we can separate the limit of x as x approaches infinity and limit of 2x plus 2 over x squared minus 1 as x approaches infinity. So this is limit of x as x approaches infinity plus limit of 2x plus 2 divided by x squared minus 1 as x approaches infinity. And this is equal to the limit of x as x approaches infinity plus limit of 2x over x squared plus 2 divided by x squared divided by x squared over x squared minus 1 over x squared as x approaches infinity. So cancel out x, cancel out 1x, cancel out x squared, and that's it. So this is equal to, simplify. So this is equal to the limit of x as x approaches infinity plus the limit of 2 divided by x plus 2 over x squared divided by 1 minus 1 over x squared as x approaches infinity. So substituting x approaching infinity, so this is equal to infinity plus 2 over infinity plus 2 over infinity divided by 1 minus 1 over infinity. So this is equal to the infinity. 2 over infinity 0, 2 over infinity 0 square, 1 over infinity 0. So infinity plus 0 over 1 minus infinity. So 1 minus infinity is equal to infinity plus 0 over 1. So this is equal to infinity plus 0 over 1, which is equal to infinity. So our answer for the limit of x cubed plus x plus 2 over x squared minus 1 as x approaches infinity is equal to infinity. Okay, so we'll go now for our last example, number 4. So find the limit of quantity x plus 2 cubed minus x minus 2 quantity cubed over x squared. So solution, expand first the numerator. So expanding the numerator, we have the limit of x cubed plus 6x squared plus 12x plus 8 minus quantity x cubed minus 6x squared plus 12x minus 8. Overall x squared as x approaches infinity. Then we simplify this equation. So we distribute the negative sign in each term. So we have the limit of x cubed plus 6x squared plus 12x plus 8 minus x cubed minus 6x squared plus 12x minus 8 minus x cubed plus 6x squared minus 12x plus 8. overall x squared as x approaches infinity. So we can see that we can cancel x cubed and minus x cubed, and 12x. So we now have the limit of 12x squared plus 16 all over x squared as x approaches infinity. So from here we can now apply the limits. So to find this limit, first divide n of x and d of x by the highest power of x. So what is the highest power of x? So the highest power of x is equal to the x squared. So we divide all terms by x squared. Okay, so the limit of 12x squared divided by the highest power of x squared plus 16 over x squared divided by x squared over x squared as x approaches infinity. So cancel out x squared, and x squared. So this is equal to the limit of 12 plus 16 divided by x squared divided by 1 as x approaches infinity. So we can now apply the substitution of x as it approaches to infinity on the terms with x. So this is equal to 12 plus 16 divided by infinity divided by 1. Infinity squared. So 16 over infinity squared is equal to 0. So we now have 12 plus 0 over 1. So which is equal to 12 divided by 1 is equal to 12. Answer. So the answer for our example number 4, limit of x plus 2 cubed minus x minus 2 quantity cube over x squared as x approaches infinity is equal to 12. So that's it for our unbounded functions. I hope that you learned from this video. Thank you.